So I copy into the Microsoft Word so that you can see clearly. So for this one, okay, so you see that this is our state space. Okay, so the first step is in your Z. I have basic type, but in this question I don't have free type, so I don't have free type lah. It's okay Then I have the axiomatic definition. Okay from this question here. Then after that, my next step is the state space schema. So this is the one that you saw just now in the lecture slide. So when you want to do your state space schema, this is where you have to imagine about what you want to store inside your database. Okay, let's say just now, I told you just now, I want to store all my team members in the badminton club and also those who are actually at the badminton hall to play badminton. Okay, so I will have two tables. So one table is to show all the members. All these members does not mean that they are playing, and they maybe become the member, but does not mean that they are playing badminton. So I have a list of all members that I will store in badminton table. And then after that, at that time, let's say today, I want to know who are actually playing badminton at the badminton hall. So I will have a list of my members, okay, who are actually inside the badminton hall. So another table, because I cannot use the table of badminton here, because badminton I may have 50, but does not mean that everybody are actually playing badminton. So what I need now is I need to know how many are playing. So I create another table just to store those who are actually playing badminton. Okay, so I have two. So two table. So this inside the table are the student list lah. In this case, I didn't put detail. I just put student. I can have student ID, student name, and so on. But for exercise purpose, I just say student first. Okay, I don't go in detail means I need to have student name, student ID, student handphone number. I don't go in detail like that. I just say student only. Means I will talk about student. Okay, maybe student name here. The record is student name, for example. So all the students who are registered into my badminton club, I will store inside badminton. Okay. Inside my badminton table, I will have many records, because I can have 50 records of student become member. I can have 60, 75 or whatever. Doesn't matter. I will have many records. How to show that I will have many records? This is where you are going to put power set. If let's say I didn't do power set. Okay? So remember in tutorial 2, we have a single record, right? When it is a single record, this is how you show a single record. One record only without power set or finite set symbol. But if you want to show that my database data can have many records of student, okay, I need to put power set symbol. When I see power set, it shows that in my badminton database, I will have at least 1 student, 2 students, 3 students, it's up to you, but I can have more than 1 student. Okay, so that is what it means by this statement. Okay, when you put power set here, I will have many students. Okay, so here power set means many students in my database, because when I talk about state space, this is the one dealing with my database, talking to my database. So my database will have many records. So my badminton variable, this is variable. My badminton variable will deal with the database. So I can talk with many records in the database. Okay, so that's what I mean by power set here. Okay, another table is hall, means that the one who are playing badminton inside the badminton hall there. So these are another list. But of course, this list is badminton member. So means that something like from the badminton member here, those who are playing in hall, I copy the name, I put here. Okay, this one playing, okay, put inside the hall. So means that not everyone from the badminton will be inside playing badminton inside the hall there. So it's still the list of students, but this list, okay, is actually related to the badminton also. So, but I need another table to show the difference. One is all my team members in badminton club. Another one, those who are playing only in the in the badminton. So I want to show two different tables. Okay, so I create another variable called hall. You can put other name lah. This one is just to show that those who are in hall, those in badminton club, you can put other name. So in those hall also, I can have many records. Does not mean one student only playing badminton sorang-sorang. No, normally seldom lah. At least two people to play badminton, right? At least. So I need to have more than one. So should be power set also. That's why here I will have power set. So if I show using my table here, I can have, let's say A, my B, whatever lah the name, C, and so on. I can have D, okay, E, and so on. I can have A, N, okay, whatever lah. Okay, okay, so I can have more than that. Okay, so these are my team members. But playing in badminton can be only B. Siapa D, E, B, D, E, and so on. Okay, I may have this playing inside the badminton hall. Yeah, so maybe, or maybe I have only 10, all 10 inside the badminton hall. No problem also. Okay, so how to show that 10? Okay, let's say I have 10, and then those 10 are playing in the badminton hall. This is my constraint. This is where you have to show that if I have 10 members in my badminton, these 10 students still can play in the badminton hall, because the limit of the hall just now in the question is maximum 20. So I have 10, all these 10 can play in the badminton in the hall there. So 10, no problem. Means I copy the whole this badminton student to the hall. Same, all same, because still does not exceed the limit. So how to show that this one does not the limit and so on? This is your constraint. This is where you add in the constraint. So this is where you see the predicate part. This is your predicate part. So I am telling that those who are inside the hall is a subset of badminton. Meaning that those who are playing in a badminton inside the hall now are actually from my badminton members club. Okay? So those who are playing badminton at the badminton hall there are actually from my badminton club. So I use subset of because I can have 20 students in my badminton, all 20 playing in the hall there. Okay, I can have that. So that's why subset of. Okay, not proper subset. But of course, because I cannot, if let's say I have 50, what happened? I cannot have 50 playing at the badminton hall. So that is another condition I have in my statement. I am telling that those who are in the hall cannot exceed the limit. Okay, cannot exceed the limit. So hall is power set student. So student, we cannot calculate 1, 2, 3. So this is where you have to add cardinality symbol. Remember cardinality symbol? To get the total number of students. The result will be integer value. Okay? So what we are doing here, we are saying that calculate how many inside the hall now. 1, 2, 3, blah, blah, blah. These are students, but your calculation is by using 1, 2, 3, 4, 5. Oh, now I have 15 students inside the hall. So how to show that is 15? That is where you use the cardinality symbol, the hashtag symbol. So your result is 15. 15 less or equals to max player. Max player is 20. Still no problem because we did not exceed the limit of 20 students inside the hall. So that is our condition, our constraint. So this constraint is for our whole system for this module. So that is what I mean by predicate part. Okay, so as I told you just now, in the state space, in the declaration, the line should be finished or the declaration will end with semicolon, meaning that at the end here should have semicolon. but we don't put. No need for you to put. Okay, no need for you to put, except if you bring this on top like this. The second line bring on top, you have to put semicolon. Here also you have to put semicolon. Oops. You have to put semicolon. Okay, but if you don't do this, okay, you do separately, then it's okay not to put semicolon. Just leave it like this. Okay, same thing for this one. At the end of your should have what we call as conjunction symbol, and here, conjunction here. Okay, so you can put that or you don't put that also can. Okay, if you want to put, you want to bring this one up, can. Okay, so you can have conjunction there. Okay, but if you don't, just put down there, then you can remove this statement if you don't want to have conjunction. Okay, so these two statements, remember just now, must always be true. So from our condition, how must be from our badminton club. Cannot be from other outsiders, not in our badminton. So we put this statement. So those who want to play badminton must be from our badminton club. So how to show? This is explained to show that. And then those who are inside the hall cannot exceed 20. So this is a statement from there. Understand? So how to read the statement? Because when you see past year questions, there are statements that you have to write in English. So this one, how to explain this statement? You just say that those who are playing inside the badminton hall must come from the badminton club. That's all. Okay, means that those who are playing must be a member of badminton club. Okay? This statement means that total students who are inside the hall to play badminton cannot exceed the limit. That's all. But you have to know how to write the statements in English language, because there are questions from past year where you have to translate a very short statement like this into English language. Okay, you have to write carefully. Okay, so this is what we mean by state space schema here. Okay, okay. So this is what we mean by our table just now. Okay, so now let's proceed. So this is your badminton club just now. Okay, and then you will need to know later how to do the variable. So normally, okay, actually in the step by step of doing Z schema, there is a small steps that we exclude in our assignment. So actually the real steps is you have the badminton club just now. Another step is to create badminton club prime. Actually this is the step. But for us later we are not going to do this. Just to let you know. I'm telling you the steps first. Okay, the real step in our original Z schema is like this. So you have the original badminton club just now. Then you have to create another one, badminton club prime. Okay? Badminton without prime is the original state space. Badminton club with prime is to show the update later. So it means that you are going to have two diagrams. Okay, something like this. Okay? Actually, this one, should have two diagrams. Okay, one for badminton, another one is for badminton club prime. This is for the update. You must have this actually. Okay, but of course we are not going to do this. This is actually the steps. The original step from last time. But we are not going to follow these steps. But I just need you to understand. Okay, originally you have to do like this. Okay, originally you have to do two state space. One original without prime, another one with prime. But of course for our assignment we are not going to do this one. We are not going to do this one. But you have to know why this one actually needed. Because you are going to declare variable with prime. Remember, variable with prime is for the updates. but we are not going to show that. We are not going to show that in our schema. So, but actually it is there. Okay, later you will see lah. Okay, so the step is you should have this. Okay, because when you do combination, you will have 4 variable actually. Okay, the original without prime and then with prime. Actually, when you combine these two, you will have like this. So without prime with prime. Okay, actually you should have this. Okay, but for us, okay, you see there's a delta here. There's a delta here. Okay, when you see delta just now, if you remember just now, this is to show that there should be an update. That's why we need the prime variable. Okay, but if you have z here, you are going to have this, but means that your variable will not have an update. Z, the 3 lines just now, or the triangle here. Triangle means there is an update. Okay, so here I put the triangle first, just to show you that later we may have some updates into our database. Okay, here, if let's say you use the z, means that it will be the same here. It will be the same thing. Just that there will be no update in our database later. That's all. Okay. Just that this symbol is to show, because normally we will have a lot of updates, so we will use triangle lah. Okay. So when you have this, okay, actually you see this one, Triangle Badminton Club, the name, Triangle Badminton Club. You have all variable here. Yeah, you have all variable prime and without prime. Okay, so in our Z schema, we are going to replace all this with just the name only. Triangle Badminton Club. So means that when you do the name only, you don't have to consider the detail inside only. Means that it's like you skip the line of putting the prime this one. You skip this part. Okay, you don't have to do the prime variable. Just do the Triangle Badminton Club later. Okay, so let's say I want to add a new member. Okay, so this is operation schema already. I want to add a new member. When I want to add a new member, okay, first thing that I have to ask myself, okay, if I add a new member, do I need to add this member into my database or not? Of course, I need to add this member into my database. Okay, that is the first thing that I need to know, to make sure that I'm going to add this member into the database. And then, if I want to add member, do I need to get the information of that member from the user? Okay, then of course I need how to enter the data into database if you don't have. So meaning that if you want to get the information from the member that you want to add, there is an input already involved into your system. Okay, and then just now you say must not exist yet into our data. So that is what we call as precondition already. So that after that you ask, I want to save into database, meaning that this is the update to my database already. When update, then you are going to involve prime variable already. Okay, so these are the things that you have to ask when you want to start doing your operation schema. What are the inputs? Is there any operation or update that involved? Is there any precondition involved or not? Everything you must ask yourself before you proceed with the operation schema. So let's say I want to add member. The condition is not a member yet, and I will need some changes to my database data. Okay. So actually, if we go for a normal step, you can see, if we go for a normal step, we have to do like this. We have to take the variable badminton called just now and prime variable. So this is the, if you are talking about delta badminton, this is before, this is the prime variable just now, this is my input. Let's say a variable, it's up to you. When your variable for input is up to you how you want to name, but make sure that you have the question mark. So question mark means I'm asking, let's say the student, what is your name? Because I want to store the name. Oh, then the student say, oh, this is the name. Okay. And then I check and they say, oh, then you have not registered yet. Okay. I will add your name into the database. So meaning that I need the input from the students, their name or the student information lah. So that is the input into my system. For when it is an input into my system, then it is a question mark variable already. Okay, so you declare a variable. So here you see others got power set, but when it comes to student, no power set at all, because one student comes, normally when you enter the data, you enter one by one, right? You can enter 10 like that. No, normally you will enter one by one. So when the student when you want to add a new student as a member, okay, so you add one student, a single record per time. Okay, a single record per time. So that's why your input variable normally without power set. Different, because this variable is local. Its operation schema is local for this operation, not the one that you put inside your state space just now. State space to communicate with your database. Here is function, local, like your local variable, like your local variable. So your new member question mark is local, because this variable is just to store, get the information, store for a while only. You are not storing this in your database yet. It's just to get the information, key in only, but the key in you haven't saved yet. Okay, you just key in the information, but you haven't saved. When you save to your database. This one, not yet. You just take the information, put there, but you haven't saved yet. So this is local only, not saved to your database yet. Okay? So, but this is input because you key in, for example, you get the information, this is input, this is local, okay, then not saved yet. So you get the input 1%, 1%, 1%. Okay, so that is the starting point. So after that, so I need to check, because when I see one input, okay, I need to check whether this student already exists in my system or not. Right, this is the first thing. So where is it? So these are from the badminton just now. The one that I am checking is this one. New member question mark is not a member of badminton. Okay, so what I am doing now, the data that I enter, new member question mark, let's say the enter is X. X is the name of the students. Now I am checking with database. Okay, remember the two variables from database, badminton and hall just now. So I want to add this student into the member badminton club, right? So which database should I check? Should be badminton, right? Not hall. Hall is those who are playing in the badminton. Those in my database for the member is the badminton database. So I need to check from my badminton database record. So that's why I need to make sure that this student, the X here, is not exist yet in my database. How to show that does not exist yet in my database? I use not a member of symbol. So meaning that the students that I want to add does not exist yet in my badminton database. Okay, so I check one by one, everything. Oh, not exist yet. True. The students does not exist yet. This is true. So then I have to update already. How to update? Okay. So now I want to update data because the student does not exist. I want to update my database already. So how to update? Okay, so you see the statement here, union. Union is to add the record into my database. Okay, so I will see that prime variable here. Set prime variable equals to badminton prime equals to badminton union new member. Okay, what does this mean? Okay, what does this mean? So I want to update database. Which table I want to update? If I want to add new member, should be badminton table, right? I will not update the whole table because that one is playing badminton. Because now this is a new member, I will update badminton table. Okay, How to update? Okay. So first of all, you look at the right side, your right side, Okay, your right side here, badminton, So what we are telling here, badminton without prime here is the original data of your database. Let's say I have 55 records of members in my badminton club. So I read all this. These are the record from badminton lah. Okay, so this 55 record, that is badminton without prime. Okay, the old record lah, the original record. Okay, badminton without prime here is the original record. Okay, I want to add the new member into the record here, make it 56. I have 55, making 56. How to make it 56? I use union. Then, because this is a record of data, I need to put curly braces, a set of curly braces, new member, question mark, meaning that the new member will be added into the database, making 56 students now. Okay, this 56 student is the updated record of badminton. So how to show updated? Equal before this. That's why badminton prime here, to show that the updated record is a combination of the old badminton together with the new member. That's how you do it. Okay, but of course you have to write like this. Badminton prime equals to like that. All the prime variable is to show the updated record. Okay, but we are talking about badminton. How about hall? We are not doing anything to the hall. Okay, so that's why here you put hall prime equals to hall, meaning that the updated hall is the same as the original, meaning that remain unchanged variable. Okay, so these are the statement. These are the explanation of the statement. But it's very long. You have this 4 here repeating every time. So how to make it shortcut? Shortcut. Yeah. So you just put this statement. Triangle badminton club. That's all. Delta badminton. Because we are changing the database. This is where you do delta symbol here. Important to put that. The rest of the one that I highlight just now, you don't have to duplicate again. Okay? Then you will have a shorter version of your operation schema rather than just now. Okay? Okay, so I'll just show you one more. Still got time. Okay, this one. So just now, we have the add member. So this is the symbol. That schema. Add member. Okay, where to get the delta symbol? This is a delta symbol, delta and Z notation symbol here. So delta symbol, make sure that after the delta symbol here, you put the name of the, so this one we are not going to do. So I remove this one. So make sure that the name after the delta symbol is this name. This state space schema name. Don't put other name. This one. And then input variable. Just now what? New member. Okay. Outside student. Okay. So this is your precondition. New member. Okay. It's not a member of badminton. And then you update badminton. Okay, prime equals to union, curly braces, new member, and then hall remain unchanged. Okay, so this is what we mean by the statement. Okay, so now let's say I want to have another operation where the students want to play badminton inside the hall. How to do that? Okay, play badminton lah. Doesn't matter lah. At hall. Apa? Add member to hall. Doesn't matter. Add member to hall. Can lah. Doesn't matter lah. You just put whatever the name. Okay, so now the student want to play badminton inside the hall there. Okay, so you are going to have an update to your database or not? What do you think? Your database will have two tables. One to update the database or not? That is the first question that you have to ask yourself. We are going to have two tables, badminton and hall. Are we going to update any of the table or not in database? Yes, right. Means that we want to add this member to the hall, right? Okay, so there is an update. So when there is an update, you just do like this. Delta symbol. Delta symbol. Okay? Your variable is up to you lah. Put member of type student. Make sure that because when you use Microsoft Word, you will automatically change to capital letter. So make sure that you update again in small letter. Okay. So now, our condition here, then you have this member already of type student. So our precondition first. Okay, what is the precondition that you will allow this student to play badminton inside the box? Okay. So means that the first one is, of course not playing lah, okay. But the first one is he must be our badminton member. So means that first thing is the member must be our badminton club member. Must be our badminton club, huh? And like you said just now, does not play yet inside the hall. Okay? The thing, another one. Any other condition related to the hall? Yes. Look back at your state space. Anything, go back here. There is one statement here. Next period. So I copy this. But we cannot have equal, must be less than. What it means here means that total cannot exceed 20. Cannot be 20 at all. Must be 19. Then you can add this person. The maximum is 19. If 20 cannot be. So it means that total players inside the hall cannot be 20 yet. Okay, cannot be 20 yet. Means 19 cannot. Means you want to add 1 become 20, no problem. But cannot be 20. 20 means full already. So must be less than max player. Okay? So there are 3 preconditions here. Okay? Then any other? I think no more. Any other? Okay? Then you can proceed with update. Okay? Are we going to update badminton or not? Badminton table. No. So remain unchanged. Badminton prime equals to badminton. Okay? This is to show that there is no update to our badminton table. But how? Yes. Badminton. Okay. How? Prime equals to all union. Okay. Member plus 1. Okay. So that's how you do the operation. Translate whatever that you want into the mathematical notation. Let's say you allow, okay, another one, can let's say now one member, I don't want to be the badminton club member already. I want to go to other club, ping pong club, for example. So, want to withdraw from badminton club. Yeah? Want to withdraw from the badminton club. Okay, so I will say that as remove member, withdraw lah, member withdraw. Whatever lah the name is up to you lah. Member withdraw. Okay, so there are a few conditions here. For example, the member withdraw, for example, because you have 2 tables, you have to check whether exists in our database or not, and not playing inside the hall. because it's saying how to withdraw. First, you have to remove the record lah. Means that you have to make sure that both does not exist. Does not exist in hall but exist in badminton. Okay? So if I want to withdraw, let's say I'm using the same variable, because you can use same variable because these variables are local. Okay, so it's okay to use the same variable. So let's say I have this, assuming that see I'll copy this one. Okay, member must be in the club and not playing in the hall yet. Okay, because you want to withdraw, must be our badminton club. Okay, how to withdraw if not in our club? Okay, so then I want to update that. Okay, so this one not exist, so I'm not adding. Here, how to remove? What is the symbol to remove? Remember? No, not intersection. Huh? Minus? Minus only for integers. That's less. Okay? So you use this. Okay. Yes? Like start. Okay? This is 2. Okay? So these are a few things. When you see later in the lecture slide, the first exercise or whatever will be simple. Then you will go to something like this. This one I make it advanced little bit for you lah. Okay, for you to understand clearly lah. Okay. Any question at here? Any of you still confused? Why I make it like this? Confused or not? Okay? But these three are operation schema. CRUD, yeah? These are CRUD. Normal CRUD, yeah? So any question at here? Any question at here? Because if you refer to chapter 2, there are example here. The first one. Okay, next week lah, I will explain again lah. Similar but it's more complex. I will explain again. Any question? Okay?